निर्मळ नो अभिगम कल्याण हो छात्र नो हरदम उच्च अभ्यास नो शिक्षण धाम महर्षि गुरुकुल महर्षि गुरुकुल महर्षि गुरुकुल महर्षि गुरुकुल महर्षि गुरुकुल.
Welcome back, students. In this session, we will study chapter 1, number system. We will study introduction and solution to the exercise 1.6, the last exercise of this chapter. Here, in this section of the chapter, we will deal with the laws of exponent for real numbers. Laws of exponents. We have gone through different types of laws of exponents in our previous classes also. Finally, we will be doing here also the same, the laws of equation. The first law, let us move on with numberings are given to you with all the laws. The first law is A into A into A into A into A. If it goes on n times, that means there are n number of A's, then that can be expressed as A to the power n. Number of times a particular number is occurring is given by A to the power n, where A is called the base of the exponent. This is called base, and this n is called power. You can say power. You can also say A to the power n. You can also say A raised to n. Different ways of expressing it. So A into A into A into A till n times can be represented as A to the power n. Let us see an example. If we say 3 into 3 into 3 into 3, what is this? Now how many times 3 is occurring? 4 times. 1, 2, 3, 4, and all the 4 3's are separated by a multiplication sign. It's a compulsion, it should be multiplied. This can be written as 3 to the power 4. 3, the number that is occurring, and the power denotes the number of times a number is occurring. This power will denote the number of times, and this 3 is denoting the number itself that is occurring. So 3 into 3 into 3 into 3, 4 times the number 3 is occurring, so it can be written as 3 to the power 4. Second one, A to the power 0 is 1. Any number to the power 0 or anything to the power 0 is always considered to be 1. Say example, we can say 2 to the power 0 is 1. You write 100 to the power 0 is also 1. You write 10,000 to the power 0. This is also 1. That means any number to the power 0 is 1. If the power is 0 with any base, the whole value becomes to be 1. Then next one, A to the power m into A to the power n is A to the power n plus n. In this law, if you see, the base is same A. The powers are changing, m and n are changing. When the base is same and they are separated by a multiplication sign, then their powers gets added up with the same base. Example, let us move on to an example. 5 to the power 3 into 5 to the power say 4. Now here also the base is same 5 and 5. When the base are same, then only this law is being applied. For different base, this law is not applicable. So now here the base is 5, base is 5. The only thing that is changing is for the same base we have two different powers 3 and 4. That means this would have been written as with the same base 5 and the power are added. So this becomes 3 plus 4 and you can get 5 to the power 7. A to the power m into A to the power n is A to the power m plus n. Moving similarly for the next law, A to the power m divided by A to the power n. Again here also the power is different but the base is same. And what is the base? The base is a, and the powers, two different powers are m and n. A to the power m by a to the power n can be written as a to the power m minus n, the power of numerator minus the power of denominator. Let us take an example also. Suppose we are given here 11 to the power 4 divided by 11 to the power 2. 11 to the power 4 divided by 11 to the power 2. This can be written as 11 to the power 4 minus 2 and can be written as 11 to the power 2. That means the powers are subtracted, keeping the base to be same. Next, a to the power m whole to the power m, that will be a to the power m into n. The powers will be multiplied. Let us see an example here also. A to the power, let us take a visit. 5 to the power 3 whole to the power 2. What does this mean? That means 5 to the power 3 comes 2 times. Power 2 denotes that 5 to the power 3 is 2 times. So 5 to the power 3 into 5 to the power 3. So that becomes 5 to the power 3 plus 3 if we apply this rule. But without going on to such details, we directly follow a rule that if power to the power is multiplied, so you can write 5 to the power 3 into 2 and this is 5 to the power 6. Moving on to the next law, a to the power m into b to the power m is ab to the power m. Now here the bases are different. One base is a, the other base is b, but the powers are same. When the powers are same and bases are different, then bases are multiplied with the same power. There is an example. Say 2 to the power 3 into 3 to the power 3. Now here we have taken an example with two different values. For a we have taken 2, for b we have taken 3 with the same value of m. The power m is equals to 3. Now if you solve it, you get 2 into 3 and go to the power that m has taken, that is value is 3. So this can be written as 6 to the power 3. Moving on to this, all we have gone through in our previous classes. This 1, 2, 3, 4, 5, 6, this we have gone through in our previous classes. Now in class 9, let us introduce one more exponent, that is nth root of a to the power m. This is what we say as nth root of a to the power m, that can be written as a to the power m by n. Let me recall you, when you were studying in standard 8, you have learned the chapter squares and square roots, cubes and cube roots. So suppose you were asked, find the square root of a. Then here there was nothing written here. This is automatically understood that here we have 2. Because if you remember, we were making pairs of similar numbers to take one number out of the square. So pairs in this we were making, that means here we have 2. Here the power of a is 1. So this can be written as a to the power applying 1 by 2. 1 the power of a, and this is square root, that is why divided by 2, applying the rule. Nth root of a to the power m is equals to a to the power m by n. Suppose you were asked to find the cube root of a square. Suppose the cube root of a square, that this would have been a the power of 2 as it is, and the cube root means this is upon 3. Similarly, for any root, you can say fifth root of a to the power 3. Suppose fifth root of a to the power 3. This would have been written as a 3 as it is and upon the fifth root. So this is one more law of exponent that we will be going through in class 9. That is nth root of a to the power m is a to the power m by n. One more we will be moving on, say number 8. That is a to the power minus m is 1 by a to the power m. This is what we will be going through. The next exponent, a to the power minus m is 1 by a to the power m. Let us take an example. If I say a to the power minus 2, that means 1 by a to the power 2. Or you can say, let us take a digit also. 5 to the power minus 2 means 1 by 5 to the power 2. You can take 5 to the power minus 3 and 1 by 5 to the power 3. Minus 4 is 1 by 5 to the power 4 and so on. In this way, these are the laws of exponents that we will be dealing with in our exercise 1.6. Moving on with some more examples related to the laws of exponent. Let us read the example number 12 from your NCERT textbook, where we are asked to simplify. What we are asked to simplify? We are asked to simplify this question. 2 to the power 2 by 3 into 2 to the power 1 by 3. Then big 2 is given to us 3 to the power 1 by 5 whole to the power 4. Then 7 1.5 divided by 7 to the power 1 by 3. And the fourth one 13 to the power 1 by 5 into 17 to the power 1 by 5. Let us do it one by one. This is 2 to the power 2 by 3 into 2 to the power 1 by 3. If we observe it, so this decimal point denotes a multiplication sign. We have a common base 2 and 2 and the powers are different. Then which law of exponent can be applied? So here we can apply a to the power m into a to the power n, that can be written as a to the power n plus. This is the law of exponent that we can apply in that particular question in bit 1. So apply that, let us do it. What is our solution? We are applying this law. This is 2 to the power 2 by 3 into 2 to the power 1 by 3. This can be written as a to the power n plus n. So the base is 2 and the powers are 2 by 3 plus 1 by 3. M here. This is my m, this is n as per the laws of exponent. A, the value of a is 2. So 2 to the power 2 by 3 into 2 to the power 1 by 3 can be written as 2 to the power 2 by 3 plus 1 by 3. And solving the exponent part, we can write, we can take the LCM 3, then this is 2 plus 1, this is 2 to the power 3 by 3 is 2 to the power 1, and that can be written as 2. This way we will have to simplify what is asked using laws of exponent. Which law of exponent? Here in this question we use this law of exponent. So finally we have got 2 to the power 2 by 3 into 2 to the power 1 by 3 as 2. Moving on to bit 2. 3 to the power 1 by 5 to the power 4. So again here also we can apply a law of exponent. What was that law of exponent? A to the power n whole to the power n, or you can say a to the power n whole to the power n, whatever it is given, and which can be expressed as a to the power n into n. This is the law that we will be applying in this question. So let us apply. This is my solution power. This is 3 to the power 1 by 5 to the power 4, and this can be written as 3 to the power 1 by 4 into 4, so this is 3 to the power 4 upon 5. So this is the final answer that we will be getting. It is not necessary that every time you get the final answer as a simple digit without any exponent or a simple digit with power 1. It is also possible that you will get that the power can be a fraction also. So we can just stop here. And 3 to the power 1 by 5 to the power 4 has been simplified as 3 to the power 4 upon 5 using the law of exponent. A to the power n to the power n is a to the power n into n. Moving on to the next bit 3. 7 to the power 1 by 5 divided by 7 to the power 1 by 5. If you remember the law, we will be using the law a to the power n. A is same, the base are same, so this is a to the power n with two different powers, and this would have to be written as a to the power n minus n. So we are using this law. A to the power m by a to the power n is equals to a to the power m minus n. So let us solve this. This is 7 to the power 1 by 5 divided by 7 to the power 1 by 3. This can be written as 7 to the power 1 by 5 minus 1 by 3. This is m minus n. Keep in mind m minus n. So you can solve the power formation of the exponent part by taking LCM. This is 7, your LCM is 15. So this is 3 minus 5, and this can be written as 7 to the power minus 2 by 15, and we need to remove this minus sign also. We have to make it positive, and here we will be using the identity a to the power minus n is 1 by a to the power n. So this can be written as 1 by 7 to the power 2 upon 15. So it's too small to write here. 2 upon 15. 1 by 7 to the power 2 upon 15. So this is the finally simplified form of what was given to us. 7 to the power 1 by 5 divided by 7 to the power 1 by 3 is 1 by 7 to the power 2 by 15. Moving on to the next one. Big 4. This is 13 to the power 1 by 5, 17 to the power 1 by 5. You see, the powers are same but the base are different. So we can apply here the law of exponent as a to the power m into b to the power m, and that can be written as ab to the power m. Here, this law is applied. So, the solution, we can say 13 to the power 1 by 5 into 17 to the power 1 by 5. This can be written as 13 into 17 whole to the power 1 by 5. We just have to multiply what is there in the bracket. So 17 is a 51 1 5, and 221 to the power 1 by 5. So this is the final answer. On simplifying 13 to the power 1 by 5 into 17 to the power 1 by 5, we get 221 to the power 1 by 5. In this way, by applying different laws of exponent to different types of sums that are given to us for simplification, we can simplify them. We can simplify them using laws of exponents very easily. So for that we need to remember, we need to memorize all the laws. So keep in mind, you need to work out on mainly what are the laws of exponent and the laws of exponent, how to use that laws of exponent, and those laws of exponent should be used appropriately for appropriate questions. Exercise 1.6. Let us move on to the solution for exercise 1.6. Question number 1. Find. There are 3 bits, bit 1, bit 2 and bit 3. The first one we have to find 64 to the power 1 by 2. This find also here means simplify. We need to simplify them as much as possible. 64 to the power half. We need to find the factors of 64, all the factors of 64. But try out with the smallest factor. If you listen, then you should try out with the smallest factor. Try to find out the prime factors. It is not compulsory that you will be getting it in prime factors only. You can get it some other factors also. But for that, you will have to understand the question very clearly. We need to focus on the power also. But if you move on with the prime factors, automatically it will be simplified. So let us find the factors of 64 somewhere here. This is 64. 2 32, 2 16, 2 8, 2 4, 2 and 2. So you have 1, 2, 3, 4, 5, 6. So you can write this one as 2 to the power 6. 64 can be written as 2 to the power 6 and the power as. Now you can apply the law of exponent. Which law of exponent? You can apply e to the power m whole to the power n is equals to a to the power mn. This is the law that you can apply. Applying here, you can write this one as 2 to the power 6 into 1 by 2, and you apply this law of exponent. Now simplify, this is 2 3s and this can be written as 2 to the power 3. And what do we mean by 2 to the power 3? 2 to the power 3 means 2 comes 3 times. So 2 into 2 into 2, and this is actually 8. That means 64 to the power half is equals to 8, what we get on simplification. Let us move on to 32 to the power 1 by 5. We have just done. Let us see from 32 we have how many factors. Let us do it one more time. 2, 16, 2, 8, 2, 4, 2 and 2. This can be written as 2 to the power 5. 32 can be written as 2 to the power 5 and we are given 32 to the power 1 by 5, so this is also 1 by 5. Again we will be using this law of exponent a to the power m, a to the power m, whole to the power n is a to the power m. This is the law that we will be using, and on applying this law, this reduces to 2 to the power 5 into 1 by 5. And if you simplify, 5 cancels and you get 2 to the power 1 and that is equals to 2. A simple way of simplifying it if you find the prime factors of the given number. Moving on to next bit 3, 125 to the power 1 by 3. So first of all, we will find the factors of 125. So 125, this is divisible by 5, 25, again this is divisible by 5, 5, and this can be written as 5 to the power 3, whole to the power 1 by 3. Again, if you apply this law, a to the power n, whole to the power n, you get this one as 5 to the power 3 into 1 by 3. Which law we have used? We have used a to the power n, whole to the power n is a to the power mn. This is the law that we have used, and cancels 5 to the power 1 and 5. Try to answer every time in every step which law are you using. That would make your sum very clear to the examiner, that we have applied such and such law of exponent, and that is because of that law we are doing this. So be very clear when you are applying any of the laws of exponent. Next question. Question number 2. Find. Again we are given with 4 bits and we need to simplify each bit as we have done in question number 1. So let us try. 3. What I have told you, that we need to find the factors of 9 and try to get the prime factors or the smallest factors that is possible by you. So 9 can be written as 3 into 3. So that is 3 to the power 2 whole to the power 3 by 2. And now we will be applying a law of exponent. Which law? Again 3 to the power m whole to the power n. That can be written as a to the power m into n. Because this is the form of a to the power n, 3 to the power 2 to the power 3 by 2. So let us apply that law and we will be solving it. 3 to the power 2 into 3 by 2. Now this 2 and this 2 cancels. So the final answer on simplification is 3 to the power 3. 3 to the power 3 means 3 times 3. So 3 into 3 into 3. And that is equals to 27. Now on simplifying 9 to the power 3 by 2, we obtain the answer to be 27. Moving on to the next bit. 32 to the power 5. 32, we have seen 32 can be written as 2 to the power 5 whole to the power 2 by 5. And again, by applying the law, a to the power n whole to the power n is a to the power mn. And if you solve it, this is 2 to the power 5 into 2 by 5. 5 cancels. This is 2 to the power 2 and that is equals to 4. Moving on to the next question. 16 to the power 3 by 5. The same way as we have proceeded in bit 1 and bit 2 and question number 1 that we have already done. We'll be simplifying this also. This can be written as 2 to the power 4. 16 can be written as 2 to the power 4. If you get the factors of 16, that is 4 2 times. 2, if you multiply 4 times, then you get 2 to the power 4 as this way. If you want to know, this is 8, this is 2, 4, 2, and 2. This way we obtain the factors. And this can be written whole to the power 3 by 4. Again applying the same law, a to the power m whole to the power n, that is equals to a to the power m into n. So a to the power m whole to the power n is a to the power mn. We can simplify as 2 to the power 4 into 3 by 4, 4 cancels, 2 to the power 3, this is again 3 times 2, so that is what we got as 8. 2 into 2 into 2 is 8. With 4, same as we have done earlier, 125 can be written as 5 to the power 3, and this is whole to the power minus 1 by 3. Applying the same rule, 5 to the power 3 into minus 1 by 3, because we know a to the power m whole to the power n is a to the power n. So this 3 and this 3 cancels, and we get 5 to the power minus 1. You can write this one as 1 by 5 to the power 1, because we know a to the power minus n is 1 by a to the power m. This is also a law of exponent that we have there. So the final answer is 1 upon 5. So 125 to the power minus 1 by 3 can be expressed as 1 upon 5 in its simplest form. Number 3, the last question of the exercise, which has 4 bits, and we need to simplify each. So let us simplify which one first. 2 to the power 2 by 3 into 2 to the power 1 by 5. This types of questions we have done in examples also. We will have to use laws of exponents to solve it. And here, if you observe which one, the base is same, the powers are different. So which law of exponent we should apply? So we should apply a to the power m into a to the power n is equal to a to the power m plus n. This is the law of exponent that is applicable here if we observe it very clearly. So after this step, we can write this is 2 to the power 2 by 3 plus 1 by 5, since base is same and powers are different, so powers are added keeping the same base. So we have to solve the powers by taking LCM. So this is equal to 2 to the power. If we take LCM, this is 15, 3 5s are 5 to 10 plus 5 3s are, so this is 3, and this is 2 to the power 13 by 15. So this is the simplest form of 2 to the power 2 by 3 into 2 to the power 1 by 5. Moving on to next bit 2. This is 1 by 2 to the power 3, sorry, 1 by 3 to the power 3 whole to the power 7. Here if you see, we can apply the law. This is a by b to the power m is a to the power m by b to the power m. This we have seen in the laws of exponent also. So applying this, we can say this 7 is applied to both numerator as well as denominator. So we can say 1 to the power 7 divided by 3 to the power 3 whole to the power 7. Now this can be again simplified as 1 to the power 7 is 1 comes 7 times. So this is 1 by, and this will be 3 to the power 3 into 7, and the law we have used for here is a to the power m to the power n is a to the power m into. So this can be again simplified as 1 by 3 to the power 21. Every time the law that we are applying is that we are writing each and every time which law has been applied, therefore easy understanding. Moving on to bit 3, next 11 to the power half by 11 to the power 1 by 4. Again the law here is a to the power m divided by a to the power n is a to the power m minus n. If you see, we have a common base, that is common a, and the powers are different. So continuing with the question that is given to us, this can be written as 11 1 by 2 minus 1 by 4. Now simplify, the power is to be solved. 11 to the power, and the LCM be 4, so this is 2 minus 1, and this is 11 to the power 1 by 4 is the simplified form. Moving on to bit 4, this is 7 to the power 1 by 2 into 8 to the power 1 by 2. If you observe it, the powers are same but the base are different. That means we will have to apply the law a to the power m into b to the power m is actually a into b whole to the power m. This was the law that we have dealt. So we will be applying this law because they have same power and different base. So this can be written as 7 into 8 whole to the power 1 by 2, and this is 56 to the power 1 by 2. So in this way, applying different laws of exponent, we can simplify different forms of exponent. That means laws of exponents are very helpful in solving such types of simplifying questions.